Good morning. Even though it's just about 9 o'clock and we're scheduled to get started, our projector isn't working. So we're going to try to wait a couple of minutes and hope that it shows up. If not, we can run, I think most of us have some sort of device we can look at slides on, and we can run from the posted slides. Obviously, that's not the best way to go, but we might have to. So if you want to start pulling them up, we can either get it from Materials Manager or from the Tools pages. My bet is if you just Google DETNET IETF 94 agenda, you'll find it. I'll try that too.
I'm not sure if we understand how it's going to work, but we keep an eye on it. Yeah, this is fine.
So while we're waiting for the projector to come up, we will be taking minutes using Etherpad. For those of you who haven't experienced Etherpad, the link will show up in a moment. But it is a way of multiple people editing the same document. And we've already put the agenda into it. Please feel free to add your notes. Everyone is welcome to contribute, even just a sentence or two. Even just looking at what else is going in there and correcting it. Also, feel free to add your name to the end if you'd like to be recognized for helping to contribute to the minutes.
Okay, good.
Try to detect. Did you hit apply? Ooh.
Yeah.
All right.
All right. Okay, this is the DETNET working group. If that's not what you intended to be attending, you're in the wrong room. Deterministic networking, just to give the long form. Lou Berger and myself, Pat Toller, are chairing, and our secretary is going to be Yoni Korhonen, I think. Yoni. So Yoni, unfortunately, is unable to be with us physically at this meeting, but I understand he's attending online. And then you can get the online agenda and slides in the meeting materials page, and working group information on the tools page. So, okay, here's the IETF Notewell slide. And then I'm going to let Lou take over for
Okay, because this is the first time we're meeting, we'll go over some things we normally do and go over some things we don't expect to do again in the future. Out of curiosity, how many people in the room is this the first working group that you're going to participate in? Sorry, I'll try again. Maybe I'm in need of some more coffee also. How many, can you raise your hand if this is the first working group that you're going to participate in the IETF? Ever. I just want to see how many people are new to the IETF. Because if you're new to the IETF, there's some information. If there were more people who are new to the IETF, we'd spend more time on some of the introductory stuff. Given that there's not too many people here that seem to be new to the IETF, we'll skip that, or at least go through it pretty quickly. As always, our audio is being both streamed and recorded. We also have Meet Echo happening. If you're presenting, there's a pink box. They ask that you stay in the box, but if, like most of us here, we don't mind leaving the box, so that's okay, but do not leave the microphone. Please make sure to keep talking into it for both the recording as well as the remote participants. When you come to the mic to make a comment, the mic lines, please state your name. This is important for the minute takers. As I mentioned, we have Etherpad going. There's just two others beside me in the room. Please join in. Please jump on the link. Please contribute to that. It's really quite helpful. We also have Jabber, and I'm going to try to monitor the room, but if anyone else wants to help monitor the room, that would be great. We've already gone over where the agenda and slides are. There are blue sheets being passed around. As always, we ask you to put your name on there. It really helps us figure out what size room we need the next time we meet. The agenda is driven by our core deliverables. In the future, the agenda is going to be driven more from participation and discussion on the list. We're new, so we haven't had a whole lot happening yet since the working group formation. We expect that to change and hope to have both working group documents to be discussing as well as following on to discussion to help resolve issues. Next. All right, so going on now to the area of topics that we don't expect to cover much in the future meetings, but we think it's important that we hit on in this first meeting. The first is, what have we been chartered to do? The charter is pretty much aligned with what we discussed at the BOF, but there are some changes in specific language, as well as some changes in deliverables. As I'm going through this, please feel free to, if you have a question, to come to the mic and ask. Even though it's a pretty formal setting, we don't have to be so formal in dealing with questions, and we have time to discuss, so let's use it. So in terms of the deliverables, the architecture, data plane, data flow models, Yang, those are pretty much as we had discussed in the BOF, and I think are not substantively changed. There was some discussion during our chartering on whether or not whether we needed a formal problem statement and requirements document. And the feeling was that it was important to not get so focused on informational and background documents that the real work got lost. And that's why these are listed as if needed in the charter. It's not to say that we don't want to document or preserve the work that's already been done. For example, we had a nice set of use cases already written. It's not saying we want to throw those out. It's just saying that's not a core deliverable of this group. The core deliverable of this group is the solutions. not the informational document that are background. And we don't want to get caught up, as some groups have, in focusing on those informational documents and not making progress on the solutions. Given that we're the IETF and our real product is protocol specifications or BCPs, the IESG really wanted us to make sure to focus on those deliverables rather than the informational deliverables. The other really interesting one that got added in was encryption. This came from the security area. And there's been a bit of a discussion about what's called opportunistic encryption. And basically saying, let's encrypt where we can, when we can, even if it's not perfect security. So let's not let the objective of perfection stop us from doing the good. And I think in this space, a lot of folks are a bit concerned that throwing in encryption in the path will unnecessarily complicate processing, as in complicate your chips that you're going to go build to support this. The other is as a user, there's concern about the latency that encryption may add, or the change in the data plane behavior. And so this is on here as something that is good to investigate. It's not a hard requirement, but I'd also point out that 802 has some good mechanisms here that basically deliver the same type of really opportunistic encryption in the form of AE and 1X, where the users don't necessarily aren't conscious that that encryption is happening. So I think there's also good precedent for technologies that we can leverage. I'm not saying we're going to use those here. I'm just saying that it's not as foreign from, I think, the backgrounds of participants than you might first think when you hear opportunistic encryption. Before we go on, does anyone have anything that they'd like to talk about with respect to the charter?
Eric Nordmark, just to wake people up a bit. No, but there was one thing I was wondering, because I was rereading the charter after you guys were chartered, and there was this one sentence there about the data plane and compatibility with 802.1 TSN. And I don't know whether that's a significant constraint, because I thought, we're going to have some IP headers, MPLS headers, whatever in here, right? 802.1 doesn't have that in their data plane today. So I didn't quite understand how much of a constraint that is, if it's just we'll figure out some gatewaying thing at the boundary, or what the intent is.
So from my standpoint, DETNET is going to run over multiple subnet technologies, of which 802.1 is one of those. And you said that 802.1 doesn't have MPLS or IP headers today. Sure it does. That's how we run IP and Ethernet, IP over Ethernet and MPLS over Ethernet all the time. So I don't see it as any different from that. There are differences in terms of sort of the service being delivered, and we're going to have to figure out how to tie those together so that we can bring in the resource management and allocation that's going to happen at the DETNET level and map that to the functions that are at TSN. But in terms of where I think you're talking about in terms of payload and things like that, it's no different than what we do today. It's just another subnet technology.
Okay.
Hi, Norm Finn. It's very possible that that sentence came from the idea that currently in the 802.1 standards, a stream of interest has to have a multicast destination MAC address. And we would like this, I think many of us would like to see this work for an IP unicast stream. And that needs to be discussed, worked out. We need to figure out what we're going to do. And I think that's what that stems from.
Yes, so it sounds like there will be some mapping to run on a particular subnet technology, right? And that's where this will come in. Yeah.
Right. Okay, we're going to move on.
I thought I'd interject one other thing, which is I think we're probably pretty likely to have a problem statement draft. I don't know that we will actually bring that to RFC, but it seems like a good thing to to run our work, to help kind of just make sure we know what we want to do. I tend to feel that once you have a problem statement and requirements documents, they start to get a lot of redundancy between them. And so my leaning would be to say, let's focus on having a problem statement that makes the requirements clear enough as part of the problem statement, and not try to maintain two documents that need to be kept in sync there. So that's kind of the thought, to keep our busy work down.
Yeah, and I think that's a good example of where the as needed comes in, that we see on the slide. In terms of milestones, we have a base set that's driven obviously from our charter and the other items called out in our chartering document. The first ones are having a working group document for use case and problem statement. You'll notice that those dates are pretty close. The reason for that is we felt that the documents, the individual documents that were discussed at the BOF, are sort of reasonable starting points. And we'll talk a moment about, we'll have a slide that has process, but we won't spend too much time on it because there's not too many new folks here. But it's important to recognize that when we say adoption, this is the starting point for the working group's activity in an area. It's not saying that there's working group consensus on the contents. The contents, when it has working group consensus, that's when we go and publish it. It's a starting point. We expect modifications. We expect there'll be disagreements on particular areas of the document. We expect there'll be changes. Certainly during the polling for working group acceptance of any of the existing documents, if you have something that you think needs to change in the document, that's a fine time to bring that up. You can say, yes, you support a document, but you'd like to see a change, a specific change in an area. That's great information. But just remember, when we say adoption here, that's the start of us really engaging in that particular area for the working group. And we think that the December dates, you know, whether it's the 15th or earlier or later, are pretty achievable. And that's not to say there won't be change in the documents both before and after. In addition to the use case and problem statement document, we also have on our milestones an architecture document. Again, we think we can use what we have as the start, not the end, the start. And we also highlight the data plane specification. Now, you'll note the data plane specification is in April. So we have some time before, but we also don't have any good candidate documents in that area. So while the date we have time, we don't have good examples to draw from to know that we're going to achieve that April date. To sort of foster the discussion, we asked Yoni to put together something that'll start our discussion on there. And you'll hear that later in the agenda. Now that isn't a document yet, a draft, an individual draft yet. He does expect to publish one based on the discussion that Shram is actually going to give. But the reason I'm talking about it so much is I'm sort of leading towards a plea for alternates or additional contributions in this area. If you have interest in the data plane, if you have thoughts on how the data plane should be supported, please put them down and throw them into a draft and publish it. If you don't really feel like publish it to the list and it'll get picked up in the other document or somebody will pick it up. But this is an area where in terms of these first four deliverables, personally, that's the one I consider highest risk because we don't have a good basis for that yet.
Yes, Greg Mirsky-Erickson. I probably overlooked in a previous slide, but what I wanted to ask is that have you given a thought of OEM? Do you see it as a separate document or it's a part of the data plane?
So OEM is explicitly discussed in the charter. It's important that we cover it. As always, we're sort of a contribution-driven group. So there's opportunity for you to contribute the
Sure, okay.
as you sort of want to contribute.
Yeah.
My view is it was included both in all of these documents. So it would be included in the problem statement, it would be included in the architecture, and I would expect it to be included in the data plane. If for some reason the group wants to go, and that's why it's not called out separately here.
Okay.
If the group decides they want to run it as a separate parallel, that's okay too, as long as the solution comes forward.
Yeah, another way is probably would be at some point if architecture document as too heavy, just to split OEM requirements as a separate and then with a gap analysis and propose solutions.
So if you have some specific text you're thinking of there or specific piece you'd like to contribute, I think it would be great to try to contribute that into both the problem statement and architecture. If you want to start out as an individual as a separate document that can then be folded in, that's great. If over time we figure out that it's separate, that's okay also.
Okay.
The key thing is that the topic be covered. OEM is definitely an important and included topic. Where we end up publishing it, that we can figure that out based on how things evolve over time.
Yeah, this is Norm Finn again. I'd love to hear proposals and suggestions on what sort of things we could do for OEM in here. Some of the things that the DETNet does are necessary, do some of the things that you'd normally do with OEM need to be built into the protocols, but other things can't be, and that would be very interesting.
Yes, Sharon Devari. Yeah, two questions. One regarding synchronization and time synchronization. Is that part of the data plane, or it will be part of everything, same as OEM?
I think it is the same comment as OEM.
Okay.
We'll see how it evolves. If the authors think it makes sense to be separate, it'll be separate. If
Okay.
if the documents get written at very different times, they're likely to be separate. If it's all coming out at the same time, it's nicer to have fewer documents that don't have to cross-synchronize.
Okay.
If it's in the same document, then it's easy to make sure that it's self-consistent.
Okay.
But if we have one part of the problem solved, and we think that solution is separable from another part of the problem, we wouldn't want to hold up that first one for the second.
Sure. Second question I have regarding is traffic management also part of this charter, basically like preemption and time at rest scheduling, those kind of things?
So that's part of what we have to decide in the problem statement. I have a personal opinion. Some of what you said, I think, is specifically called out in the charter, but not everything. And whether the specific examples are or not, the comment still holds. We have to figure out in the problem statement exactly the pieces that we're going to cover that are beyond what's spelled out in the charter. If it's in the charter, certainly we have to cover that.
Okay.
But I think there's a level of detail that's going to be beyond what you would expect to see in a charter that we want to get to certainly in our solutions, which means we should be identifying them at the problem statement and adding additional levels of specification or details as we move down the document chain.
Okay. Okay.
Yeah, I would also say on some of those, some things like preemption may be best to leave addressed at layer 2, and I'm not sure that we need to do something at layer 3 to cover that, because it's kind of hard to do that unless you are closer to the media access control.
Right. Yeah, and of course, what we're going to get at to right there is what we mean by terminology. And a comment I was going to bring in the architecture document is we have to make sure to align some of the terminology from what's happening in the data plane and what we traditionally do in the IETF. Preemption is a great example. So we have service level preemption, which is something we're very familiar with, let's say in traffic engineering. That type of preemption, I certainly think we would be doing. The other type of preemption of what's being defined right now in 802.1 with the priority level preemption, yeah, I wouldn't expect that we would touch that at all. But if it's there, that doesn't mean we don't use it, but I don't think we would worry about that. That's something we would address. Any other question on the milestones? I don't think we need to go through all of them the same level of detail on these first ones.
Just Pascal Thubert, just a minor point on.
Pascal, your name, please.
Pascal Thubert is my name.
Okay. Okay.
You said it very quickly.
Do you want me to say Thubert? So that's. Yeah, the quick point was about the interface with the end device. Is it covered in the larger term OAM? For instance, if the circuit goes up, circuit goes down, do we want to signal that to the end user, to the endpoint? Right now, the prime statements say we could. That's where we are, but that's one of those things we could discuss. How far we extend? Do we start at the first network device, or do we talk over an interface to the terminal station?
So you're right. It's a good thing to bring out in the problem statement and a good thing to discuss in the context of that. I guess I'll say one more thing on the milestones. We do talk about in the future some information models. And while we're not highlighting them today, I don't want us to forget about them. And the first one, data flow information model, what we're really talking about is identifying the parameters necessary to describe a DETNet flow. That's really going to be important. We're just saying it's not the first thing we're going to work on, but we shouldn't forget about that. Being able to, without that, it'll be really hard for us to do all the other solution parts. So if you are not an author of one of the documents that we've mentioned are going to be talked about, it would be very good to look at this list and see where you would like to contribute. And if there's an area that you contribute that's more towards the top, there's probably a document already on that, but that doesn't mean you can't contribute. Talk to the authors, talk on the list relative to that. If it's more towards the bottom, we don't have documents on those topics. Please feel free to go write one and send it, contribute it as an individual contribution to the group so that we can start thinking about those things as well.
Yeah, I thought I'd also say on our use cases document, I think we have quite a good start on our use cases documents, but there are from the things that were done to support the BOM. But on the other hand, I think there's some use cases that aren't particularly covered, and if there are some additional use cases that you think should be added, we'd be looking for contributions for what needs to go in there for those use cases.
We have a few slides that I'd say are more IETF working group process tutorial things. We're going to skip over the general parts because we don't have too many newcomers here. But they're in this slide package, so feel free to reference back to them. Next slide, please. So we're not going to go over the standard pieces of working group process. Next slide, please.
Do you want to talk about the adoption?
I think we can. Okay. There's a slide in a moment that we'll talk about, which is specific to how we're going to operate. But I do want to mention our secretary, who's not able to be here, although he is on Jabber now. So we appreciate Yoni taking notes for us. Next. This is a useful statement in most working groups, is don't forget about the mailing list. A lot of times people think that the only way to make progress is to come here and talk and present. That's not really the best way to make progress. The best way is to use the list. If you have something you'd like to contribute to an existing document, you don't necessarily have to write your own. You can just send it to the list of say, hey, we'd like to see this text added. That's a fine thing to do. Or discuss the points that you have the document, or if you have something new, you can bring it to the list there. But please utilize that list. And as always at the IETF, the list is where consensus is ultimately judged, not in face-to-face meetings. So from a working group standpoint, we're planning to do the things you normally see in a working group. In addition to that, we're going to follow a process that has become fairly common in the routing area, but is not a formal IETF process, and that is conducting IPR polls as part of our both acceptance, working group acceptance, as well as last call procedures. So when we go to do a poll for acceptance of a document, before we start the poll, we're going to ask publicly for there to be a statement on conformance with the IETF IPR rules. And we will not proceed with a acceptance or proceed towards last call without all contributors who are identified in a document from responding. That doesn't mean don't list someone who contributes. Please do. In fact, would be out of process to exclude them. But it is an important step. This came about in other groups because people, for whatever reason, didn't know or didn't conform with the process, and we had some very light IPR disclosures, which ended up slowing down our process in some cases by 12 or 18 months. And often brings about threats of just destroying the whole work, of saying, okay, we got to do a major reset. We really don't want to run into anything unexpected. So this is quite important. Okay. Any questions, comments? I think we're right on time. So thank you. Next up is Ethan on the use case document.
Thank you, Lou and Pat. I'm Ethan Grossman, and this presentation is about the consolidated use case draft that my co-authors and I have put together that we believe is ready for adoption by the working group. And so the point of the presentation today is to kind of put that to you and make sure that everything sounds like it's roughly in order and is going in the right direction. Again, it's not going to be complete, but at least it'll be going in the right direction, and we've got a place to start with a document that the working group can work with directly. Next slide, please. Okay, the draft is named here, and this is the table of contents for the presentation today. We'll go over what the goals of the draft are, where the draft came from, what its current status is, what the future directions are as we currently see it. I'm going to do a brief overview of the use cases that are in the draft, but these are exactly the same use cases that were presented at the last IETF, and so I'm not going to do justice to them by going over them in detail. They were already covered very well by their authors last time, so you can look up that presentation if you want to see. I'm just going to kind of briefly touch on them to remind us and hit on a couple high points of each, but really move on then. And at the end, I put together a brief list of what I consider to be the common themes of the use cases, and open to input on other things that either seem common or maybe are distinctive, just to get an idea of the scope of the use cases. After that, we'll have some discussion. I'm definitely going to leave time for discussion, and I hope that you guys will feel free to comment on anything about the direction or just the general tenor of the way things are going with the document, such that we would all feel good about it as a place to start from. So the use case draft provides context for what we're doing, just to make sure that whatever proposed designs we come up with can be measured against it. How well do they satisfy these use cases? And also provide the answers to these questions that specifically apply to use cases. What is the use case? How is it addressed today? What do we want to do differently in the future? And what do we want the IETF to deliver? Now, I'll point out, as I will later, that the status is currently that the slides that you'll see here today follow this format very closely, whereas the draft document itself, at this point, hasn't been steamrollered through to make a consistent presentation that clearly states and answers these questions. The different drafts were written by different authors, and one of the pieces that I'm going to try to do with the other authors is to make it more consistent and to put it into that form. So that's part of our direction there. Point out the draft explicitly does not state specific requirements. It's not intended to define the scope at this point. It's not intended to suggest specific designs, architectures, or protocols. And it may be that things that are described in these use cases, some will fall inside what we decide to do at least first in DETNet, and some may fall out of that and will eventually not be part of DETNet. But this just sort of is the largest edge of the Venn diagram of all of the different use cases. So just as these are a reminder and documentation of the drafts that originally contributed to this, if you want to see the same presentation, you can see it from last time. These are all the names for reference of the different documents. You can look them up if you want to see where they originally, they'll serve as a reference for where they originally came from. And so the current status is that all of those documents you saw have been essentially cut and pasted together end to end with a little bit of organization, but not much. And that's the current status of where the document is today. So the intention is that the document is ready to be adopted by the working group if we decide to. And then once we do that, we will modify this document, but the original documents will stay in their present form. So one of the things about the current draft is that they provide a lot of detail in some areas and not as much in others. And I'd like to develop a more consistent level of detail for the different documents. So that's part of the status, is that that's clearly in need of doing. And just to point out, it's a work in progress. It doesn't yet meet the goals as we're stating here. So plan is streamline the details to the minimum required, but not less. Improve readability, ease of understanding, highlight the commonalities between the use cases, and as Pat mentioned, we're also actively seeking additional use cases because there are certainly some places where we can see gaps. One of the most obvious one being from the industrial sector, and we have some people who have expressed interest in contributing, but this is just an area that we know offhand we need more stuff from, and just in case anybody's interested. So these are the areas that I'm going to briefly touch on, and we'll just run through them real briefly. So in the professional audio area, the current state of the art is that we have separate ABB layer 2 LANs. And for example, in a production facility that has multiple studios, each studio is kind of its own LAN. And at the moment, the way it's done is that you have to have a custom software-defined, or they built a custom networking routing system to route between the networks. But it would be really much nicer if that could be just done using standard IP routing technology. So that's the way forward there we'd like to see. So share content between layer 2 segments with layer 3. In Pro Audio Plug and Play is very pleasant because there's a lot of devices that come and go. And that's sort of in contrast with many of the other applications in which you have a large system which is built up and it's pretty much what it is. It's not like people are, you would think, plugging and unplugging things. But on closer examination, it turns out that, well, actually, when a large piece of industrial equipment goes down, it's got to have another one brought up in its place in a seamless manner. And so actually, there's a lot of parallels there. Let's see. So the idea here is it would be nice to have a way to route between islands of ABB, for example, traffic. But the question always comes up, well, are you looking for just a way to route between islands, or do you also want an end-to-end solution? And the ideal solution obviously would be end-to-end. So this is the current application that would be really nice if we had it really soon. And it would be nice to go further as we go along. So the utility network use case presents its own challenges. For example, a very widely distributed geographic area, many different kinds of links in between the different nodes, and a lot of real-time requirements for the information that's carried across those links. So today that's done using TDM networks, basically telco-style networks where it's guaranteed, delivery, and there's no question of whether a packet's going to get dropped. That's the way that it's built. That means it's its own network. It's not mixed with IT traffic, and it would be really nice if they could move that from the TDM style network to a multi-services packet-based network. So theme comes up again, layer 2 and layer 3 topologies. Deterministic behavior is extremely important, but in this case also, if you think about a utility network, reliability and availability are huge. Security is huge. These would obviously make very good targets to have things go wrong with, intentionally or unintentionally. So that seems like a pretty significant requirement in something of this magnitude. It's assumed that there would be centralized computing of the deterministic paths. Again, the distributed configuration may be useful, but the intent is that it's primarily centralized. For the building automation systems use case, if you can imagine a large building, there's various sensors such as temperature, humidity, light stores, and so on. Currently, all of those live on their own proprietary field networks and are not integrated with the rest of the world except through specific controllers. The highlight here is the availability. They're calling out 99 with 4 nines availability. So there's a lot of, again, security and reliability involved in managing these large buildings. The moment the problem's identified as there's a lot of protocols, low interoperability, so it's expensive, and there's definitely security issues with the current systems. So in the future, there's only going to be more sensors, more devices, and connected to more networks. And so it would be nice to have an architecture that provides that kind of network availability and this kind of 10 millisecond to 100 millisecond polling range for communications. And if you could do that, that would be fabulous. So the wireless for industrial use case, there are sort of 2 aspects to it. One is the general use case. I mean, wireless for industrial is cases where wiring isn't really an option. For example, think rotating, portable, or fast-moving objects. Also, resource-constrained devices such as Internet of Things type things, of which there are many, and they're not really capable of interacting very much with their neighbors. They need to have things pushed down to them. Real-time, huge network with lots of things in them. Again, a lot of requirement for reliability, security, and low cost. In this market, 1% cost reduction could save $100 billion. It's a pretty significant chunk there. The way it looks today is that you have numerous wireless deterministic buses. However, they don't talk to each other and they don't talk with IP traffic. So ideally, you'd have unified network and management, which supports deterministic and best effort traffic. You'd have wide area routing and so on. In this particular case, there's an interest in using the 6-TISH time-slotted channel hopping wireless media access controller technology. And that has its place in the stack, but to note that there are a couple of technologies which we're planning on developing in DETNet, which are also in need of being developed for the 6-TISH effort, and we can leverage that work so that it doesn't have to be done in both places, including the configuration and operation for the deterministic paths, as was discussed earlier. Those data models can, to a large extent, be common. And the way that the packet replication elimination is done, all of this stuff to enable redundancy is useful here. For the radio access networks use case, we're talking about connectivity between the remote radios and the baseband processing units. We're talking about connectivity between base stations and between the base stations and the core network. So if you go through all these different connections, they're a lot of the time dedicated point-to-point fiber connections, for example, and it's often not a real network. It's just a sequence of point-to-point connections. So the idea is to develop a standards-based transport protocol and standard networking equipment that can make use of the underlying deterministic link layer services. So that's the same kind of thing everybody else wants to do, is to develop a way that all of these things can work on a single network to reduce cost and so on. So again, the data plane transport specification can be unified among those different applications and the other applications that we have throughout the DETNet space. Standard for data flow that is aware of the time sensitivity and constraints of the target network environment. So that's one of the key things that's new about these kinds of data models, is that they have to be able to express that. Okay, so that is the brief overview of the use cases as we have them to date. There's a few other that have been added very recently but haven't necessarily been added to the presentation, but they're along the same lines as these, and we'll develop those further as we go. So what I saw is the common themes. Everybody's looking for a unified standards-based network. It's extensions to Ethernet. It's not going to be a new network or a new way of networking. It's expected that it's going to have to be centrally administered, although there are aspects that require this distributed and plug and play and the ability to replace things on the network in real time without interruption. So that's a central theme. Again, the standardized data flow information models is a theme. The layer 2 and layer 3 integration is a theme. Guaranteed end-to-end delivery is a theme. Multiple proprietary, to replace the proprietary deterministic networks, enabling a mix of deterministic and best effort traffic. To allow the unused deterministic bandwidth to be available to best effort traffic, although as is commonly stated, not to other deterministic streams, because they have to have their own bandwidth to begin with. And this will enable low-cost multi-vendor solutions, which lower cost all around. Other items that came up, scalability is very big in this because the needs of one industry and another are quite different, but they're very specific in each of those. So whatever these architecture and data models develop has to be able to be scaled. For example, some people, if you're in an industrial control loop, you need extremely small timing, fine timing resolution. But on the other hand, if you compare that to a utilities network that has a huge geographic space, those two have very specific but very different requirements, and those scalability is key. Applies to the latency constraints also. Similarly for the availability, sometimes you may need extremely high levels of availability that simply aren't affordable in other use cases. And so we'd like to make these things be somehow specifiable for the network and expressible within the network. Security is huge. There's all manner of possibilities for failure attackers, bad devices, but the new deterministic stuff brings in a new angle, which is that it's not only sensitive to the packet content, as we're used to with security, but also to the arrival times of the packets. So even delaying the packets along the way can affect the behavior of the system, even though the packet is the exact same content. So it's something to keep in mind there. Of course, deterministic flows that are isolated from each other and immune to best effort traffic congestion. So that's what I was planning on saying, and I'm hoping that you all have stuff to say about this, and that you have a sense of what we're trying to do and whether it makes sense to you. I had some ideas for conversation topics, but they're not fixed. Go ahead.
My name's Charlie Perkins. I just noticed on, I think it was like 3 slides ago, that you said Ethernet, and yet 6TISH is looking at 82.15.4,
Yes.
which isn't necessarily Ethernet.
Yes.
So could you resolve that, or do you have an idea about that?
I will let Pascal take the microphone because he is the man.
Actually, I think it's a good thing for us to answer as from the working group standpoint.
Okay.
So remember, this is a use case document. So this is users saying what they want. So they don't care. Some users don't care about 6TISH. Other users who are also in this document do. From a working group standpoint, what we do at DETNet should be agnostic to a subnet technology. and work across any subnet technology that gives us the right services. So 6-dish could be one of those. TSN could be one of those.
I like that answer, but I'm just curious if it could lead to the situation, for instance, there may be 2 requirements documents.
Right now, as Pat said earlier, we're not anticipating actually having a requirements document. What we expect right now is a use case, which is going to be driven by what the users want. And we, as people supporting the users, don't get to tell them what they want. So that's the first one. The users are going to say what they're looking for. But we do expect to have a problem statement document. And in the problem statement, I would expect it to encompass all the use cases. So it would need to cover both the users who want to use 6-dish and the users who want to use Ethernet and the users that want to use, I don't know, something else.
Well, you have to admit this list of use cases is pretty broad.
Well, that's why this commonality section is going to be really important, is identifying what's in common and also teasing out what's not in common, what's unique to each of those use cases. That's going to be really important, and we are looking to the use case document to do that.
Okay,
but I think there is considerable commonality in the use cases, and some of the variability that exists has to do with scaling. In other words, for instance, when addressing the needs of a control system in an industrial machine, its distance may not be that large, but it needs very low latency for some of the control loops. Whereas for a utilities system, it needs a lot more distance, so longer round trip delay, but the processes that's running can probably tolerate the bigger latency. They're going to have no choice because the speed of light's the speed of light.
Right.
I would say that often these systems will run over mixed networks. I don't know that much that is necessarily going to be on 6-dish all the way end to end. A lot of times it's on 6-dish to get to, it's on 802.15 type networks to get the hops at the edge, and then it's going on an Ethernet. So it's very important to serve a variety of layer 2s, and I don't think those necessarily conflict with each other. They do, in some cases, in one layer 2, you may have some capabilities that you don't in another. If they're the 802 layer 2s, there are some common capabilities too that are defined in 802.1.
Okay, thank you.
Norm Finn, I wanted to make a comment. We talk in here, I think you have 6 nines of availability. I've also had some very interesting conversations with the person who is in charge of a world-class automaker's factory floor, who's told me that he really needs 12 nines of loss in terms of packet loss probability. Because if you add up how many packets are going through there and how many packets in a row you can lose, and that will then cause a machine to fail safe, and the fact that 2 shutdowns a year is too many, you actually do see numbers like 11 or 12 nines for packet loss rate. And so there are some really extreme requirements that I think we can meet.
I think that also points out why we need the industrial guys to come and help with the use case contribution.
I don't think Mike.
Yes, Shamita Chakrabarti, also a 6-Low working group co-chair. So I think I agree with Charlie's point. 6-dish is one of the technologies that may have aspects for reliability as well, but the requirements or use case document should include other constrained node devices as well for the DETNET. So I think what I'm trying to say, 6-dish is one technology, but we should be also providing deterministic networking service to other kind of constraint node devices, such as Bluetooth or radio, IoT cell sometimes, maybe it appear in the future. Any thoughts?
Yeah, you bring up an interesting point. So what we're going to be doing in DETNet is going to be agnostic to the specific link layer technology or subnet technology. And one thing we haven't had explicit discussions of, where do we document the mapping of DETNet to each particular underlying technology? Okay. And we haven't had a whole lot of discussion on that privately, publicly at all. But I do think it's something that's going to be important down the road. But I think it has to be done in the context of when we have the solution documents for what the overall solution is, and then it'll be clear how much we have to do the mapping to different technologies. But I would certainly expect that down the road that people will be interested in doing that, will come forward with contributions. This is the first time I've heard of anyone talk about IP over or DETNet over Bluetooth, for example. A year from now, will someone have a document on that? Well, hopefully we have all the other solutions to back it up.
Right. We already have a document that's on the RFC queue as we speak.
For DETNet?
So, no, not for DETNet, just for IP over Bluetooth. Yeah.
The comment was this not the first time I've heard of IP over Bluetooth. It's the first time I've heard of
DETNet. Okay, yeah. Probably we should think about that.
Yeah, and that's a fine thing for down the road.
Yeah.
I think.
Pascal Hubert, I need to answer this. There is a reason why 6-dish is especially present there. It's because it has a MAC layer that is actually capable of being programmed for deterministic features. It is a deterministic MAC. Right now, Bluetooth is not a deterministic MAC. You cannot program anything. You cannot time synchronize. You cannot do anything of those features that are programmed by DETNet. So hopefully 6-dish is representative enough of a certain world of objects that the day we do a deterministic version of Bluetooth, then we can also apply the same kind of thinking. Hopefully it will be generic enough if we can do everything in 6-dish, that we can do also Bluetooth. But at the moment, we cannot get any requirement from Bluetooth because Bluetooth is not deterministic. Right? We are doing things which depend on capabilities of the MAC layer. And TSCH is the only MAC layer that has those capabilities today in those low power things. So that's why we exhibit the TSCH.
Subir?
Subir does.
Before you go there, I think there was a follow-up question on that previous topic.
Yeah, I try to say that yes, maybe Bluetooth don't have deterministic behavior characteristics today, but they might develop something in future, or we could make sure that it's deterministic up to the Bluetooth gateway at this point. But then I'm sure there will be other technologies coming up in the future that would have deterministic. Yeah.
Whatever we develop in here, it has to be
end-to-end,
able to work over multiple link layer technologies.
Yeah.
So whether it's 6-dish today or Bluetooth, deterministic Bluetooth tomorrow, we shouldn't need to change what we're doing in this group. Part of what's good is that we have two technologies that we are talking about today for writing over, 802.1 TSN and 6-dish. So by having two, that'll help us drive towards that agnostic solution. But it's really our objective to be able to go over any appropriate subnet technology, and I'd say keep us honest as we go forward. So that's really good that you have a third interest.
Right.
Thanks.
But I would say that, to get the best performance, to get the most deterministic, lowest latency, it does need some layer 2 cooperation that basically if you run over something that doesn't have layer 2 access features in order to work with this, you're not going to get the same performance that you'll get over something that does have the layer 2 support for this. So.
Subir does. This is a question to the chairs. I think that my understanding is that, of course, that everything has to work layer 2 agnostic, but still this working group will expect some behavior, which I think Pat mentioned that, okay, here is the way you should map and the data model you should use so that you get the best performance in the deterministic features or satisfying the requirement. So the question is that how many of those linked layer technologies do you think that what time it will be determined by this working group? Okay, we'll take a first cut of 3 or 4 or X number of, and then we'll work on the mapping on those technologies as opposed to, okay, it should support all the things, because this blanket statement as an IP, it works today, right? But the objective here is to take the help and do the corresponding mapping on those specific layer 2 technologies so that that result can be really achieved by this working group. Am I correct?
I think the response is that we're contribution driven.
Okay.
So at this point, we have people who are prepared to contribute for the 802.1 TSN kind of layer 2 features and for the 6-TISH features. We would need to see what other similar layer 2s we have people coming in interested in contributing on.
Okay, but there will be a definitely time frame then by which this should come. Otherwise, the working group only work to first iteration.
I think the working group is focused primarily, and this is reflected in our charter, is
okay.
Primarily on TSN.
Okay.
And we also work with 6-TISH.
Okay.
So that's what we have on the plate right now.
Okay.
I expect that is enough for us to drive the working group effort without waiting for anything else.
Okay.
But that it's also reasonable for the other people who have other interests to bring those forward as contributions.
Okay.
But that's not going to gate our work. Certainly, if a third technology comes up and we've missed something, that'll be very good to catch that sooner rather than later.
Okay.
So it's not that we don't want to hear about those other technologies, but we don't have to wait for anything else before we move forward.
Okay.
And I think if another technology comes along later, in 2 years, say there's a deterministic Bluetooth technology and they want an additional RFC to say how that maps in. That's always something that can be done as
So
a
I think thanks for the clarification.
I mean, there's kind of what's in our initial work, and I think we've got a pretty good meaty area with a lot of use case and a lot of interest in implementing it out there. But as far as what's the cutoff date, hopefully we do this work, and then as things go forward, if there's more that should be added, we build on it.
Right.
Yeah.
And what's the cutoff date for new technologies that IP runs over?
Yeah.
Right.
Right.
That's an ongoing.
Yeah.
thing.
So my
an important point is those things can even come up even after the DETNet working group is closed.
Sure.
So we can't. We're not going to say there has to be a specific time.
Right. So I think that's the reason actually I got up and asked this question is that we cannot then say that's okay, that whatever we do in the first, to support the first use case will just apply all wireless technologies, right? It's just a specific, in 60s is definitely runs over 15.4 networks, no other wireless networks, right? So from that perspective that.
I'm sorry, I didn't parse what you said. I think I heard you say that what we're going to do here is going to be specific to a particular technology. If that's what you meant, absolutely not. I completely disagree with that statement.
Yeah, but the question is that how, if we just focus on Ethernet and 60s, right? So that means that we nail down two wireless, layer 2 technologies, and it's okay. We cannot say that it works across all, for example, all wireless technologies. It will not work, right? It will only work with 15.4 because that's where the mapping will be done, correct?
I think we have a good existence proof of the IETF being able to define generic technologies in advance of the specific underlying technology being present. So we're hoping to continue on that sort of approach with what we do here. Will we be successful? Time will tell. But I think we have a good existence proof that this, as a body, that we can do such a thing. Will we get it right? We're probably not going to get 100% right. Can we get really close? Hopefully.
I just wanted to also say that there are a number of wireless technologies that 802.1 TSN applies to as well. So it's not just 6-TISH, it's 802.1 TSN, which applies to both Ethernet wired and to wireless 802 technologies. So
yeah, a good point, Norm Finn. 802.1 is not tied to any particular one of the dot groups, .3, .11, or whatever. Right now, we're just finishing up so that actually everything that TSN has done is applicable in some sense to .11, .16. It's, you can argue as to whether it would be useful if naively applied to .11, but also when you look at the problem, and those, I see a lot of IEEE 802 people in there, are several IEEE 802, they know that my hot button in IEEE is not tying these standards closely to 802.3, not tying them to a particular specific technology, because when you look at the problem space, and also not even tying it to routers versus bridges, although layering is my God, when you look at the problem of how long does it take a packet to get from here to here, to here to there, and at what reliability, all there are boxes, links, and queues, and clocks. That's all you have. And it doesn't matter whether it's L3 or it doesn't matter whether you're decrementing the TTL as you forward it, and it doesn't matter whether it's Ethernet or a wireless link, and it doesn't, a lot of things just really don't matter in this space. And hopefully we can keep it that way, where we have to, to be useful, it's got to be tied to some kind of technology. And I'm sure Ethernet is one of them, but we want to keep it open.
Pascal Hubert, what I like with the two examples is they are kind of extremes, meaning that hopefully we'll support a lot of stuff in between those two. So one is a very high speed, wired, the other one is very low speed, low power, wireless. In the middle, there's a lot of space, right? So I trust that by taking those two extremes, we're actually making a good choice. The other thing is, just like 802.1, TSCH was defined on 15.4, but there is little to zero tie with the file layer, meaning that we could take this same abstraction and place it on many other file layers. So then again, we are not specifically tied to something.
Liang from China Mobile. A few comments on the use cases. I saw the use cases addressed now have many overlaps with, the use case has been discussion very popular in 5G. For example, you have the network utility networks, and you have the mobile backhaul and front haul. They have been discussed in many organizations that focusing on 5G use cases. For example, in NGM, we have the ultra reliable, ultra low latency use cases, and we have the extreme real-time communication use cases, which is very time sensitive as well. So I have a suggestion that we may consider, well, it's a suggestion for the working group, maybe we can have a specific category of use cases facing 5G vision, because we already have some of the use case raised here very related to those characteristics. So which make it also well, I mean, and because 5G has been popular discussed recently, and for our operators, we're also very interesting to have a technology that in IP layer, that protocol to actually address that use cases. So it's just a suggestion. Yeah.
So the great thing, as has been said a couple of times, is we're driven by what text is provided by the group. So what you've just said, it would be great if you took a look at what's in the use cases right now, and if you think something's missing, put some text together, send it to the list, send it to the authors, and then we can discuss whether we should include it.
Yeah, sure. Yeah.
So that's great. Thank you.
So you're still accepting use cases, because that's
we're
contribution
driven.
Yeah.
So if someone comes out and says, you missed this, or I really want it included, and here's the text, then we can consider it. Without that, we can't, without that, it's not going to be added.
Yeah. All right. Thank you.
Yeah. But there actually was a slide where that was one of the things on one of the early slides was that whether there were some use cases that should be added, and we certainly can do that if we have contributions.
Okay, so one of the questions on that last slide, once we find it, was whether or not this was ready to be a working group document. So again, the question is this, well, let's start out with this. How many people have read the document? The use case, how many people have read the use cases document? Again, arms, please. Okay, so it's a reasonable number, but not a huge number. How many people think that this document is a good foundation for the working group's work in this area? Not that it's done, not that it's fully baked, but a good foundation to start. I'd say it's about almost the same number. So, you know, I think it's a reasonable place to start, but it's also something, as always, we will confirm on the list. Part of the discussion should be is if you have specific reservations, don't wait for the poll. If you have specific reservations, bring them to the list immediately. That would be great. Okay, assuming we have no more comments, we're going to move on. Now to the problem statement draft. Pascal.
Thank you.
Okay, so this is about the problem statement draft that we have written almost 2 years ago and developed since. So it's already quite a mature document. The current version is version 4. So what I'm going to do this time is not go through the document or everything that's in it. Since we are looking for adoption, what I'm going to do is kind of highlight the specific points which may be debatable and which would be great discussions for the next version of this document. The first item which is of interest is those two sentences are coming from the charter. And that's related to text we initially had and then questions we got from Alia during the AD reviews, which is really, can we apply DETNET to the internet at large? Or should we be defining a scope which is more limited, to which we know we can actually apply this technology? And in that case, the question is really, what is that scope? It's not obvious. In some cases, we have the Pro-Audio network, which is like a San Francisco citywide or kind of network. Next case, it's smart grid, it's all over Canada. So what's the domain? Is it a geographical prime? Is it a organizational prime? I have this single administration which can manage my network. So one of the big issues, prime questions, that this document will have to address is, okay, what's the scope, how large, what defines my DETNET network? We have some text, and we don't start from nothing, and here is basically what the draft says. I will, if I have a laser here, I hope I do. Is one of these things a laser? Yeah. So I will point you on this fourth item here. So what this is saying is one of the criteria, and we had the discussion with Ethan, one of the criteria for how large of what the scope of what the size of my network could be that I can actually have one controller controlling it, some reasonable size for something that I can control with a controller. And all of a sudden comes the question, hey, but if I have two types of networks or two things kind of heterogeneous, maybe I want at least two controllers. Now the question becomes, 1, 2, how many controllers? What really defines my network? So I really expect to have some discussion on that point, because that's one of the critical things that we have to write, define, agree upon in this problem statement document is what's the size, what the scope, what defines my deterministic network. And next thing that the document does is summarize the requirements. So it's not a requirement document, but we kind of list what we understand they are as a starting point, so as to express the problems that we have to solve to actually address those requirements. So that's basically listed. It's almost a copy-paste of the text in the document. So there is this rough listing of requirements. And then again, if you have any comments that these are actually the requirements that we are looking at, please step up. From this, we build a document with the structure that we have here. Interesting piece is here we have written section 4 related IETF work. There are only 2 items. We are obviously missing quite a bit of them, as some people told us very reasonably. So if you are inclined of helping us describe this technology, we are looking for authors who could help us fill the gap here. Which technologies could be of interest for DETNet, something coming from T, whatever. If you're an expert, if you want to express, oh, I've got this technology, I don't know, out of my mind, PCE maybe, then please step up and come and help us write. You'll see it's a few paragraphs per technology, just to express what it does, so that the user or the reader could figure out, oh, that could be something that I could use for my DETNet solution. To express what deterministic is, we have this section 3, which really tells you about, oh, we have this latency constraint, we have to synchronize stuff. So we lay basically the ground for expressing what the primes are. And with this, we have the prime statement per se, which is section 6. And from there, we took one decision. The decision was, okay, we could have listed, we need to solve this problem, we need to solve this problem, we need to solve this problem. And at some point, one problem would be, how do I compute those paths? And we had this early discussion forever and looking at the trends in the market, that there will usually be a centralized controller. Most of the architectures around, that's not true for the initial Pro Audio, but most of the architecture around, if you really want to solve complex optimization problems, if you want to defragment your network, if you want to re-optimize your network, if you want to dynamically add new paths to your network when it's already quite loaded, you find that controller-based architecture is pretty much what you want. So we took the assumption in one branch of the prime statement, what if we actually have this approach? What if the architecture, and we know we already had the architecture document starting, so what if the architecture wants to actually develop the ideas of a central controller? That's a new set of problems. So we went down that path. We dived into what if it's a controller, here are the problems that this controller would have to solve. And so that's why there's this, it's almost in the solution space, right? If we are saying, oh, it's a controller. Well, it doesn't have to be. We also have some text which says, what if it's not a controller? But most of the text, the largest branch is by far the branch which says, if it's a controller, then you've got problem A, B, C. And that's basically what the document is today. We have a clear text saying, this is not in scope. There was the question earlier about timing. How do we exchange time? Do we use 1588? Do we use TikTok? Do we use whatever else, the .1AS? Well, the assumption in the prime statement, it's not in scope for us. That's not what DETNet will be looking at. We'll pick the time synchronization from somewhere else. Same thing goes for the shapers. I mean, like Pat said earlier, there are things which are really done at layer 2. That's true for preemption. That's true for shaping. And so the idea in the prime statement says clearly, we are not considering those things. They are better left to lower layer.
So just an observation here, if I may, Taro Mashkanu. That's good, that's very good. But still, I believe that this points to the fact that because the work is so interrelated and there are clear dependencies, we probably need in a specific document to have something like relationship to IEEE work statements, maybe sections that basically show for each specific piece of work what is the dependency. I'm not speaking about this document, which is kind of generic, but I'm speaking about the other like solution documents that we're going to design down the road.
So you're actually making a comment that might be appropriate to the architecture document, you're saying?
Probably definitely the architecture, maybe other as well.
Okay.
Yes.
Yeah, it may well be reasonable to have a statement here or in the architecture document about assumptions about the capabilities of the layer 2 technology to support this, or either assumptions or kind of desired features of a layer 2.
Exactly. So the point is that I'd like to try to avoid the situations that we actually find ourselves in other working groups where we have made maybe for a long time an assumptions about way things work in the sub-layers, and those assumptions didn't really prove to be true.
Yeah. So if I could summarize, you think it's okay in this document to have general technologies identified, but in some other document, perhaps the architecture document, you would like us to clearly document any constraints we have to particular technology.
Exactly. You put in better words that I did.
I think that's a great comment. Thank you.
Yes, I fully agree. That came to my mind when Samita came up with the wireless low power things. And basically, my knee jerk was, you need those things at the MAC layer so DETNET can talk to those things and program them. If the MAC layer does not have them, what can DETNET do? And so you're basically making this code more general, and I completely agree that should be a section in the architecture. Doesn't mean that we cannot improve this. We try to actually lay some information about what the layer 2 does, so we could probably put timing in there as well, which I think it's also a good idea. David?
David Blackman, I think I'm wearing my transport area working group co-chair hat. Real fast request. As you think about assumptions, don't limit yourself to layer 2. Consider layer 3 assumptions and dependencies to be in scope also, please.
So yes, basically those two items, we kind of thought them from one angle for the prime statement, so we'll have to have another angle of the same items in the architecture. So that's from Norm's notes, basically. Okay, and there we go. So went through this. So a large chunk of the document assumes a certain DETNET architecture so that we can express what we want to do if that's the architecture, what are the primes that needs to be solved if this is the architecture. So the reference architecture that the prime statement has in mind is quite classical in the DETNET space, with an application controller, then a network controller, your network devices, which are represented as switches, but they can be switches, routers, etc. I made that very ghostly, and the endpoints. So the first thing that we have to do is report the topology to the controller. So it's a problem which is really specific to the case where you have a controller. So report the topology, the neighbor, the capabilities of the devices, queues, timers, everything that the devices can do. Then once the network controller has this, it's ready to set up some path. And to do that, there needs to be some application requirements. So there must be a language, a way to express those requirements. So that may need to come from this group, or that may come from somewhere else. We have to define if we do that at some point. But basically, there must be a way, which is an application layer way of expressing what needs to be done. And from there, the controller should be able to define path. Eventually move other paths to other circuits to make room for this new circuit or things like that. And then the PCE because that's really what we see here. The controller should install some state that we have to define in this group into the devices. And then the devices has to perform shaping and whatever perhaps behavior upon those individual flows that must be indicated by some flow ID. So that's basically what the prime statement says should be done in the case of a central control.
Norm Finn, quick comment. So that you understand, I would not anticipate a relay device down there, a bridge or router, answering to, certainly no one port, output port on a device would answer to more than one network controller. So that's important. It has the control of this part of the network. And the other thing is that you can easily imagine more than one application or service controller.
Norm, is your comment more the detailed architecture, more on the detailed architecture or relative to the problem statement? Because one of the comments I was going to make is I'm not sure that this discussion belongs in the document at all.
You're right. This just should probably be more not, well, it's the title is architecture.
I know, but so the title of the presentation is problem statement. So I was going to ask, you know, Pascal, if he thought that this would continue to be in the document or not. Now that we have a working group and now that we have these formal documents that are coming out.
There is this assumption that there can be either a centralized or non-centralized or a distributed solution, right? And if you just say, okay, the architecture will have to define if it's centralized or distributed, then we cannot dig into what are the primes if it is centralized. So it's not like we're not saying in the draft, it has to be centralized. We actually say it could be also distributed, and here is what you do, but we don't dig that much. But if you want to go into the reprimes, then you need to figure out, you need to fork this and go down the path. So that's why there is this tax.
highlighted that those other areas are not appropriately documented in the current document.
Correct.
So feel free to add some text on that related
Sure.
to PCE about what
Right.
exists and throw that, Tim. When we get to, if we get to a point where we need changes to any existing protocols that are within the IETF, it already says in our charter that we won't do them. We'll work with the respective groups. So PC is identified,
Right.
TEAS is identified, 6-dish is identified. There's a whole bunch there. And if it's outside the IETF, we'll do liaisons with those organizations that own those technologies. We're not intending to hijack anyone's technology.
Sure. And one more thing related to your PC as a controller, there's another parallel work, a PC as a centralized controller, which will be addressed in TEAS and also PCE. And then architecture is very, very similar, although parameters may be different. So I just wanted to mention to you.
Yes, and that really tells me that you're welcome. You're invited as a co-author for this piece here, where there should be entries for PCE and others and keys and all those things. That's really missing here. So welcome. If you join us at the end of this discussion, we can have that talk. There was one last slide about what's in scope. They said what was not in scope. And then the prime statement basically says here is what we need to look at. We need to figure out what kind of interactions we have. So is it a centralized or distributed model? What are the flows over the southbound interface, not the northbound interface so far? So how the network controller talks to the network, but not how the application controller talks to the network controller. And could be worked on. I mentioned that earlier on the mic, whether we work on the UNI, user to network interface, between the terminal equipment and the first network equipment to inform, for instance, that the path was set up, it's usable, or the path was broken and stopped sending packets, or here is the tick at which you need to send your packets or whatever else. So this is to be debated whether we want to actually work on this UNI or not. And then it's a lot of information model. So how do you describe your topology? How do you describe the capabilities of your devices? How does the controller come back to install path? What kind of information about this path must be established? How do you tag the packets, etc.? So there is basically this list of things the prime statement says we need to solve. And that's it for me.
Okay, thank you. So moving on now to the architecture document, I think Norm. Thanks, Pascal.
Hiya, I'm Norm Finn. You just saw Pascal. Michael Johas-Tiener is the chair of the IEEE 802.1 time-sensitive networking task group. And we cooperated to generate this architecture document. This is what I'm going to talk about. I'll just talk about it instead of tell you what I'm going to talk about. The objectives of the architecture document are we need an architecture to, well, you can read it, but to provide assured maximum latency and extremely low packet loss rates for fixed bandwidth critical streams. Okay, and that's important, what kind of streams we are offering this service to. We'll talk a little more about that in a minute. Those streams go across a mixed, bridged, and routed network. We want to take advantage of 802.1 TSN standards insofar as we can, and I think we can, without disrupting existing qualities of service, and while adding or modifying as few concepts and hardware requirements and protocols as possible. Okay? And this is very important because we want this to be a new, just another feature you can add to your network. We're not interested in reinventing networking in order to do real-time things. There are several solutions out there in the market today that require particular topologies, or that require that you use a very low fraction of the bandwidth, or make other requirements on your application and provide you a way to do a real-time application over Ethernet, or they only work in bridged networks and don't work with routers. There are a number of point solutions out there
That's not what we're interested in. We want just another feature for anybody's, any kind of network, and then we have something that can grow and blossom with the market. Some non-goals. First important one, critical streams have fixed bandwidth, so congestion control via feedback and/or throttling is simply not an option. Okay? I'm generating the data. It has to be consumed in a reasonable amount of time. You can't tell me wait. Secondly, tunneling through an L3 network to connect different L2 domains is something we don't want to preclude, because that's something you can do today in a network. We don't want to change anything you're doing in a network. It is entirely possible that some users will want exactly that, but we're not a bit interested in limiting to that, because many of our use cases are already too big for an L2 network. So making the L2 network even bigger by tunneling through L3 is profoundly uninteresting to a number of our use cases. A third point is that, and Pascal mentioned this, precise time synchronization is typically required by these target applications, and some of the queuing mechanisms used by 802. Defined in 802.1 that provide absolutely zero guaranteed congestion loss with diff-serve principles, okay, which is really cool. Diff-serve principles, zero congestion loss, not low, okay, depend on synchronized time among the relay devices, okay? So while that's important to us, we think precision time synchronization is going to be very important. We don't need to get into phase lock loops in this group. Thank you very much. There's lots of people doing that. Love them. I love it when they talk that way, but you know, frequency domain and all that good stuff. But we don't need to deal with that. The current status, if you've downloaded this, you'll see slightly different numbers. O2 was uploaded this morning to replace the expired version of 01, which some bonehead didn't get out before the deadline, namely this bonehead. Now, essential aspects of the architecture, I decided to go for brevity rather than pretty pictures. Number one, you reserve resources and then have low-level mechanisms that you configure to carry out your reservation and make sure you don't lose anything. Of course, worst case, guaranteed worst case latency and zero congestion loss go hand in hand. You know, love and marriage, can't have one without the other. Secondly is the seamless redundancy aspect, which is that you sequence, you add sequence numbers to a stream if it doesn't have them. You send it over 2 or more paths or 2 or more trees. These could be multicast. You can have intermediate points in the network where you recombine them, throw away the duplicates, and regenerate the stream in order to have islands in the network such that you can have failures in several places and you still get there. And somewhere near at or near the destination, certainly you reassemble the streams and get rid of the duplicates. And the third is defense in depth. That is, it's very important in a converged network where you have a number of applications sharing the same network infrastructure, that a misbehaving stream can't screw up other misbehaving streams. As soon as you're doing diff-serve kind of things, you have one queue shared by a number of streams. A talker that's reserved 200 megabits goes running off at line rate. You can't have that causing other people's packets to get thrown away. Now, of course, that depends on the application. Some applications say, if anything's broken, the application's down, don't worry about it. Other applications, you're sharing infrastructure, and that's very important. Interestingly, there's a tie-in with security here, and then you can go ahead. The tie-in with security is that I don't think there's anything fundamentally different in what we're in any of our applications in terms of security from any of the other from lots of applications we've seen. Okay, I don't think there are any fundamentally new things. Except for timing. Okay, all the encryption in the world won't prevent a man in the middle from slowing down and speeding up packets in subtle ways that will screw up your application and have a potential of causing the roller coaster to fall over. Okay, so in that sense, there is something new in the security sense. But interestingly, such activity by someone with evil intent is really indistinguishable from a software or hardware bug of the kinds that we expect to see and need to defend against also. So it turns out, I think that defense in depth aspect is likely to be most of the security issues that we have. Okay, there certainly will be specific things, and we can talk about those, but I think that's about the only thing that's significantly different from the stuff we've all done. Yes.
Manuel Bocelli, just connecting a few dots from like various things that have been said so far with the presentations. I think we need to maybe clarify something, because if we say we want to be scalable, we want to have zero congestion loss, and we want to have no throttling, I think we're going towards magic. So we need to be very clear what we mean by scalability, and we need to be very clear what we mean by zero congestion loss and everything like that, because all that doesn't compute in my head. And I guess from any outsider who would hear these conjunction of requirements would think the same, right?
Okay. I'll speak to that for briefly. We're used to, I think most of us in this world, we're used to using weighted queuing as our primary means of doing quality of service. Okay. If I'm sending a packet to you and you're sending a packet to Dan and he's sending a packet to the next guy and he's sending a packet to the next guy, if I don't happen to have any low priority traffic and I dump my high priority traffic to the next guy and he doesn't have any low priority traffic, so Patrick dumps all of his priority stuff to Dan, and then Dan is stuck with a whole lot of low priority traffic and he can only send that out at half that rate. Poor Dan has to buffer all that stuff, right? And so if I'm limited, if I've got 1.7 megabits total of data that's critical, and I limit myself to exactly 1.7 megabits, and Patrick limits himself to exactly 1.7 megabits, and Dan limits himself to exactly 1 megabits, turns out you can still screw up, but it's pretty darn good, we found in practice. If we then take one step further, and we're time synchronized, and each one of us, this is not necessarily what everybody's going to do. This is not necessarily what every application is going to need, but this is a possibility. We're defining it in .1 right now. And Patrick says a double buffer that swaps on clock ticks that are synchronized with everybody else's clock ticks. And Dan has a double buffer that he's swapping once every clock tick, and so on down the line. And if every stream is defined as n bit times on the wire per cycle, then as long as I protect it at the entrance, make sure I'm not getting any more data than that, every packet spends roughly the same amount of time, one cycle at every hop, and gets passed on in synchrony through the network, and you have absolutely zero congestion loss.
Okay, but
so it is possible.
That's throttling then.
Pardon?
You're throttling somehow, right?
No, I'm not. No, well, excuse me. The source guarantees he's not going to send data any faster than, absolutely. And we enforce that. Of course, absolutely essential. That's why, number one, the goal, critical streams have fixed bandwidth. Critical streams have a fixed maximum bandwidth. You can't guarantee to not drop an arbitrarily high load. Yes, that's foolish. Okay, good. That was your it was much simpler than that. I apologize for the long-winded explanation. I'm really good at that.
And by the way, in the document, you do also say that you shape. I think that's what you were referring to in terms of it's not really throttling, it's shaping.
Right. So I want to point out that one size doesn't fit all. Different applications and different verticals make use of different techniques. For one application, zero congestion loss over a ring network that can heal quickly is just fine. For another application, they'll need, when you want, if this fellow with the manufacturing floor that says he needs 12 nines really thinks he's going to get it, and I can't say he's wrong. He's going to want everything in the bag of tricks. And certainly, I've mentioned, Pat, we just had a big discussion. The reservation model includes application controllers for QoS, applications controllers requesting QoS for streams from a network controller. Now, there are open issues. One is, are the existing in-progress shapers and schedulers, these are mostly in 802.1, sufficient? There are, of course, shapers and stuff defined by IETF. That's a question we have to ask. I think they are. Number one. Two is, our diff-serve techniques, shall we define in-serve? This is kind of a funny thing. The two techniques I just described really are diff-serve. But I also said I absolutely have to defend against a running open talker, somebody who's streaming at data, line rate when he's supposed to be going at 30 kilobits, right? I have to protect my resources against that. So that's sort of per stream, per port. That sort of has to be per stream, certainly near the sources, and perhaps in the middle of the network. Because bridges and routers can break too. So at some point, at some level, I am absolutely looking at individual streams and at least checking them. And when you get into the details of what it takes to check things on an individual basis and then throw them into a diff-serve queue, it gets it's a gray area as to which one you're doing. So that's something what I'd like to do is not specify that and just make sure we have the knobs on the outside, because ultimately all we need to specify is these knobs produce these observable results. So we have to provide the right knobs. We have to say these are the observable results. We don't necessarily have to specify all the details of how you do it in the middle. Yes?
David Black, diff-serve doesn't have anything to say about not checking individual streams at the edge.
Yeah.
And for the class of behavior you want here, you bloody well better check at the edge, because you let something in you didn't want to. Your damage propagation could be truly impressive.
Absolutely right. And not only do you check at the edge, you also defend at the edge, so that if somebody you don't trust, some random PC that happens to be connected to the network that hasn't made any reservations, gives you traffic with the critical diff serve, you got to map that away, make sure you don't pollute your pretty queues with uncontrolled, unregulated traffic also.
Right, and there's precedent for that also. I won't go down the rat hole here.
Absolutely, absolutely, absolutely. So a big question is, which techniques for stream identification and sequencing for QoS and pin down paths are suitable in a mixed bridge and routed network? Now, right now, the 802 stuff depends, and it's fairly important to the 802 stuff, that each individual flow has its own VLAN ID destination MAC address pair. So that I can look at any packet, look at the destination MAC address and the VLAN, and I know which flow that packet belongs to. Okay? Now, it's entirely possible that between me and you, I have 16 individual flows, only one of which is critical data. Okay? And so maybe most of it takes the direct path, but this critical thing, because it's really critical, it's going to take two paths, one going around that way, one going around that way. But as far as my application is concerned, because I don't want to go into every app, and this is important, I do not want to acceptance. I do not want to go into every application and say, you have to write your application to the DETNet spec. You have to send your critical data in a completely different way than you send the other data. Okay, I want the controller to say, oh, that's a DETNet stream, so it gets around this way, and that's okay, and duplicated and so on. All right, so what I'm getting at is there are two different problems. One is how to identify a stream for applying QoS. To the extent it's diff serve, that's easy. You look at the DSCP, right? To the extent that you need to route particular flows on a funny path, I can imagine doing that based on looking at the 5-tuple and doing an open flowish SDN-ish thing and sending it a weird way based on that. And I'm sure that's a technique that will be used, okay, in some small networks, but we know that doesn't scale so well. And at some point, I think it would be much nicer to have something on the packet that says, at some point it comes out and it gets modified and gets put in something that says, this thing is on that funny path. Now, is that MPLS labels? That could be an MPLS label, for example, that we pick out those packets, stick them in an MPLS, in an LSP, and send them on some path. There are issues when you do that. I take an LSP, so between these two LSRs, I've got 5 bridges, okay? That packet needs to have a multicast destination MAC address VLAN combination that is unique for that stream, okay? So, that's just something we need to handle, something we'll have to talk about. So there are lots of questions that we need to nail down in that area. I think the answers, I've got some ideas. I know other people have some ideas. I think they're actually pretty similar. I don't think this is hard, but it's something that's right now an open question. Finally, in the current 802.1 standards, we have a peer-to-peer, we do not have a controller in the current existing published standards. We do not have a central controller. It's all done via talkers and listeners sending messages to the bridge, and that information propagating among the bridges. We have a peer-to-peer control, a peer-to-peer protocol for setting up the reservations, for making reservations. We are going to a model. Janos is working on this. Lots of guys in .1. We're working on a central controlled model that permits you to do it with central control. The question is, do we want a peer-to-peer protocol that goes bridge, bridge, router, router, bridge, router, router, bridge, bridge, destination to set up a reservation without a central controller? Some users think they would like to see that. I don't know. That's something to talk about. Plans are, we have to decide whether the architecture draft is a suitable starting point for an architecture draft. And if so, let's get it going. Fire away.
Any comments? Yeah, I guess from my standpoint, go back one. In terms of whether it's a suitable starting point, that's really easy. We only have this on the table. So sure, it's a suitable starting point, but then we have to answer the second one is what kind of things we need to do to it. So it's a candidate for a good working group document. And I think the first thing is the document was very helpful in its current form to help get this working group started. But some of it is redundant now that we have a use case document coming down the pike. We have a problem statement coming down the pike. So it'd be good to sort of flush out or flush those parts that are redundant and clean that up. And then there's some other sort of more detailed comments that I have that I think are more appropriate just to take offline. And I would plan to do that after this session. And that's the thing we were talking about, that whoever's interested in talking more about it, we can do that in sort of a more hands-on session. And then the results of that, we can come talk across the working group. But I suspect other people who've read the document have similar comments, so it'd be really good if those folks either say them now or come to that the sort of working session afterwards. Your choice. But personally, I think it's a really good starting point, but I also don't think it's quite ready. I don't think it's far, but I don't think it's ready. I think the other thing is what you have here is one candidate architecture. Once we have a working group document, I think there's going to be other candidates, and we have to go through the process of working through the candidates and open issues before we'll have a final architecture. So a lot of the questions that you talked about, I think it's going to take some iteration by the group and input from the group to get to the eventual answer. But it's okay that happen as a working group document. It doesn't have, we don't have to have the document ready to be called for last call before we adopt it.
John Dowdle, Airbus. Brilliant presentation, thank you. I remember you said somewhere in the slides, one size does not fit all. I can see that if there are huge variations in availability, reliability, whatever, then you'll end up with architectures that could be very expensive for people who don't need that kind of availability. Is it an intention in this draft to create a small set of candidate architectures rather than one single architecture?
Good question, in the sense that I understand your point. I think my intention is certainly to have one architecture that has a broad enough scope, broad enough applicability, and enough options that it satisfies these different needs. The fundamental idea and the fundamental change that an application has to live with is that today application doesn't necessarily make a reservation before it talks, okay? Somebody has to make a reservation or you can't guarantee anything, right? You can't guarantee everybody everything with finite resources, okay? So given that the target is streams with a maximum bandwidth, and given that the target that the mechanism for doing that needs to be lay down a path, lay down resources along a path so that you can make some kind of guarantees, that sort of fits all of these things. And then the details are in which mechanism do you use to enforce the guarantee, and which mechanism do you use to create the reservation? You know, is it configured in NVRAM before you power up the system, and so on? I think that we all know how to do that easily enough that that one architecture will fit all those models.
Okay, so you might end up with a set of Lego blocks that you can plug together if you want a bit more reliability, whatever.
Well, if you have other techniques, bring them in. I mean, for instance, FCE. Okay, I've had people talk to me about, isn't there something you can do with, you know, encoding is doing all these marvelous things with storage and so on. Isn't there something there that would help you out? Okay, and as far as I'm concerned, just like I have this passion for DETNet, and so I'm coming to IETF and says, I can help you guys out. I can give you more features. Isn't this cool? If there's a proponent for coding schemes, clever network coding schemes and forward correction and stuff like that, who can come in and say, look, I can improve this, I can help you out. By all means, I want to hear from you. Okay.
Okay, thanks.
Yeah.
Pascal Hubert, there is one thing that Tom said, but was in the flow, is he pronounced the word option. I mean, it's one architecture, but there are a number of options in there, meaning that for one particular purpose, you may pick option 1, 2, 3, but not 4 and 5. There's one example that was given at the end that was about the RSVPT type of path elaboration. And okay, you won't use all those interfaces with a controller if you use a AT RSVPT model, but you can still use what's defined to tag the packets. You can still use what's defined to protect the flow from other flows which would overload or anything like that. So there are still a good number of components from the architecture which will work and that you can apply even if you don't have the central controller, and those options should be the same whether you have the central controller or you don't have the central controller. So that's really hope. So it's still one architecture with options.
Hi, Craig White. I would like to, I think he was saying network coding. I would like to, say a +1 on that. But there seems to be one thing missing in the architecture that we typically leave out that I think is very important here, and that is some kind of operational feedback mechanism that needs to be explicitly said, because, for a variety of reasons, I got a lot of ideas, but just in general, I think that there needs to be much more feedback all the way back potentially to the application in this.
Please elaborate a little about what sort of things you're talking about.
I'm thinking, so let's say you have two paths, you have or you set up a string. Everything's working, a host begins misbehaving, sending more than he's asked for or was guaranteed. It now gets dropped. Okay, so now it's not so important that you're dropping it. Appropriate behavior, you're protecting the network, but the end needs to know that that guy has misbehaved. That's why you're not getting your packets anymore.
Right.
And the same becomes even more important when it's a misbehaving middle box, a router bridge that has started foaming at the mouth, or is even worst case scenario, say flipping a bit that ends up putting it into someone else's diff serve queue.
Okay, yes, good point. We can only go into so much here, but I will mention that in 802.1, in the document that I'm editing right now, 802.1 CB, and in a new document that we're just starting, 802.1 CI, we're including things like when you're combining a stream, if you're not throwing away half the packets, you raise an alarm. Okay, because that means you're living in a fool's paradise. Okay, one example. Second example, in QCI, 802.1 QCI, we want to watch for missing or repeated sequence or excess packets. And if you have excess packets, there are a variety of things you can be actions you can be programmed to take. One is throw away the excess packets. 2 is shut off that stream entirely. 3 is shut off the port, the complete port entirely. And the reasoning behind this is that in your analysis, your error analysis, when you're designing your application, you have to design for errors. Right? One of the things you have to design for is you don't get the packets you expected, right? So what are you going to do? You're going to fail safe, shut down, do something, right? So you've got all these things. Now, when you're doing your error analysis for how you're going to react to different errors, I lose every 101st packet is a tough one to design for. And if the transmitter is replicating every 4th packet, there's all these weird things. But I guarantee one thing you have designed for is a link fails. Okay, so you can the idea here is that in some of the standards we're doing, if you get a failure that's kind of weird, what you do is you turn that into a failure that you do know how to understand and that you know how the system will react to, which increases the chance of failure, which is why Lindbergh flew a single engine plane instead of two engines, etc. So it's really complicated.
I'm not talking solutions. I understand. I'm just saying
Absolutely.
that in the
Needs to mention it.
architecture document, we typically do not include that because we have all of this stuff to say when someone says it. And I'm saying this particular case seems like a place where we should try to say something about it up front in an organized, systematic fashion so that you don't end up with this protocol or this extension or this thing to do some edge case, something. We thought about it in the beginning. It's part of the unified architecture.
Good.
This is the way it will be handled.
Good.
That's all.
There is some text in
I
there.
don't
Check
care
and see
the
if it's
solutions.
sufficient.
I got a bunch. We all have
Good.
a bunch. I'm just saying, in the architecture document, it seems that that piece is missing.
So a good comment. Please, when he does an update, make sure that it's reflected. We are beginning to run tight on time now.
Yes.
So we had two people at the mics. Let's go to the back one first.
Okay. Rick Taylor, to follow on to Craig's comment, that feedback loop, allowing somewhere documented in here to say, and this is how you would pass that information back up to the hosts on the edge or the sources of this data. It's not just the unplanned case where your stream has been set up and it's running. In a big system, things can be planned to be changed within the lifetime of some of these applications. So some mechanism where the application be told a change has occurred, change the rate you're sending this stuff or you're expecting to receive it under a managed circumstance, not just the unmanaged.
My name is Bechet Sarikaya. The problem or the issue I have with your draft is that, in an architecture document, you want to see, at least I want to see one page or one slide pictorial representation of the architecture. I couldn't see that in your draft. The use case draft talks about controllers, lots of things, and so on. So that could give you a good idea how to make a pictorial representation of what you want to say about.
That's something to try to come up with. Yeah. Thank you.
Okay. So we should.
There's several pictures, but there's
Norm
a tub full of text.
Okay. Thank you. Thank you. Appreciate both the presentation and the discussion. Shrub?
Also, where are the blue sheets? Has everybody signed the blue sheets? I assume not. Okay.
Who has not signed a blue sheet? Okay, pass the blue sheet to those people, please. Thank you.
Sorry. There's
Okay, hi, my name is Shahram Devari. I'm presenting this data plane for DETNet using pseudowires. This slide has been prepared actually by Uni, but he's not able to attend this meeting, so I'm presenting on his behalf. So the kind of co-authors are Uni, myself, and Norm. So before I start, because the whole slides is related to what we call seamless redundancy, I just want to give you like 1 minute summary of 802.1 CB seamless redundancy in IEEE. So this is very similar. So basically the source duplicates a packet to two different paths, but adds the same sequence number to the packet. When the other end, the receiver receives it, whichever path, it doesn't matter from which left or right it receives it, whichever packet it receives first, it will accept that for that sequence number. If it receives that sequence number again, it will drop it, discard. So it's almost guaranteed that it's going to receive a packet at least from one of the paths. Okay, but here what we're going to do is we're going to propose that because the pseudowire has a control word, and the control word already has a sequence number, so we may be able to reuse that for the purpose of DETNet. Okay, So as a background, DETNET expresses QoS in terms of delay, minimum, maximum delay from the talker to listener, and also in terms of the packet loss. And packet loss can be in normal operation when there's no failure, just congestion loss, and they can also be lost due to failure, link or node failure. So there are three techniques employed by DETNET to ensure that the QoS is guaranteed. One is called zero congestion loss. So this is mainly based on DETNET architecture, using reserving bandwidth, reserving buffer, reserving queues, doing proper shaping. For all the, if you do all of those, then hopefully you will have zero to or very low congestion loss. The other aspect of to achieve this QoS is to do traffic engineering or pin down paths. So basically you calculate to find the best path, and then you nail down that path from the talker to listener. And the third one is the one that is what I just told you, seamless redundancy, which means you duplicate packets to two different paths, and then at the receiving end, you're going to receive one of them at least. So also, this is just a citation from the charter. It said this work will document how to use IP and MPLS to support a data plane method of flow identification and forwarding over layer 3. So for that reason, we are trying to use pseudowire and LSPs. Okay, so what do we have today is for zero congestion loss, I think there are already mechanisms available to reserve, reserve paths, reserve buffers, proper queuing and scheduling. For the pinning down the paths, also there's lots of mechanisms available. You can use OpenFlow, SDN, I don't know, you could use RSVPTE. The third one is the one that is not right now in our toolbox available, which is the packet replication and discard. We have some part of it, but not the whole. So so it assumes that basically we are going to reuse, as I told you, the A2.1CB concepts for seamless redundancy. So seamless redundancy, as I told you, involves three capabilities. One is to add a sequence number to the packet. Second one is to duplicate the packet or replicate the packet to multiple copies, send it on two different paths. And the third one is to accept the receiver part, to accept the first one that it receives and then discard the rest of them. And this can apply to both unicast and multicast traffic. Okay, so from pseudowire perspective, actually, the replication of the packet is already available from, and the adding sequence number is also already available. So the only part that is not right now available is the discarding part, which we will discuss a little more. So here we are going to analyze three different cases. One is just sending A2.1CB Ethernet traffic that is already carrying seamless redundancy tags or A2.1CB tag through MPLS network, which is very straightforward, just tunneling. And then the other two are providing the seamless redundancy for standard Ethernet packet or for standard IP packet using pseudowire, so routing pseudowire redundancy. So here is a figure actually from the A2.1CB. It shows I have laser here. Yeah, so it shows an end system here on the left side, A, talking to an end system on the right side, G. In the middle, there are a bunch of relay systems. There's a relay system here. And then some of the relay systems, they duplicate the packets, and some relay systems, like here in the F, it receives packet from one direction and from another direction, then it can eliminate one of them and just forward one copy. So if we go back to the RFC that describes the pseudowire architecture, this box at the bottom that you can see is kind of a PE device modeling. So there on the left side, there are what they call NSP, native service processors, which in our case will be like Ethernet or 802.1cb. Those are the attachment circuit processor. Then there's a forwarder, which decides how to forward the packet using MACDA lookup, for example. And then there's a pseudowire instance, which adds pseudowire label to the packet, control word to the packet, and then or sequence number, and then pseudowire instance goes out. So in this scenario, if you want to just tunnel a 802.1cb packet, which is already has its own seamless redundancy tag, through the MPLS network, that's easy. You just send it, through two different pseudowires, because the 802.1cb or in this case the NSP will do the duplication. It will create the duplicate packets at the Ethernet layer, and then the pseudowire or MPLS just sees two separate streams. It just sends them on two different. Basically, MPLS network is unaware of this seamless redundancy going on. Just it's in the 802.1cb layer. So there is nothing to do here. It's already supported. So what we are more interested in this is this one, supporting the yeah, this is the reverse direction of what I just told you. This one is supporting a normal Ethernet traffic going through a MPLS network, but still providing this seamless redundancy behavior. So in this case, the NSP is not aware of seamless redundancy. Packet just gets forwarded, normal MACDA VLAN forwarding, gets forwarded by forwarder, and then when it reaches the pseudowire, also pseudowire instance also forwards it normally, just adds a pseudowire label with tag label with a control word. But at the LSP layer, we are going to use the protection switching for LSP, like the 1+1 protection switching, for example. So what you can do, the pseudowire will go to two LSPs, LSP1 and LSP2, same pseudowire label, same control word, everything. And the other end, when it receives it, which will be the next slide, it has to discard one of those. Whichever it receives first, it will receive it. The other one it will discard, and then it will merge the traffic back to the. It's already a single pseudowire. Yes.
Okay. If I understand correctly, you don't replicate targeted LDP, so the pseudowire signal between endpoints only one.
Yes, there's a
right. But you suggest that you use 1+1 LSP,
yes.
But on an ingress PE, you need to explicitly send to each LSP. You cannot use Ethernet replication, any Ethernet trick to send to different LSPs.
No, can you repeat, sorry, this part?
On ingress PE.
Yes.
Right. So to send to two LSPs.
Yes.
How you
yeah,
achieve
the 1+1
that?
LSP protection, it will automatically.
Oh, so basically you constitute their 1+1 protection,
yes,
and pseudowire knows about it.
Yes.
Okay.
But the only problem we are using the sending part is the 1+1 LSP protection, but the receive part is different. That's what makes this work a little different.
Right. You can do on egress PE whatever you want,
exactly.
Arbitration, which stream you select.
Yes, but today you can only select one path, and unless that path fails, you go. But here we are going to select packet by packet. We are going to select.
Right.
Yes.
Okay.
Exactly. So yeah, so on the receive side, as you can see, just one second, so on the receive side, when I receive from two LSPs, I'm gonna today, if you do 1+1 LSP protection, you're gonna receive from one LSP all the time. Unless that LSP fails, then you receive from the other LSP. But in this case, the behavior that we are proposing is a little different. You receive from both LSPs, and for the same sequence number, you're monitoring both simultaneously, both LSPs, which that sequence number, if you receive it from any of those LSPs first, you're going to accept it, and then you're going to discard the other one. So it is possible that you start alternating between the two. That's completely acceptable in this case. Okay, and another problem with the 1+1, for example, protection switching, one of the problems is if you select from one path and then if that path fails, you switch to another path, there are in-flight packets that are going to be they will be lost, the in-flight packets. In this case, there will be no loss. There is no in-flight packet that get lost. So there are, A2.1CB, there are companies that actually advertise it as zero packet loss technology.
I think calling that a form of pseudo-wire redundancy is better than calling it a
Yes.
form of
Seamless.
1+1.
Oh yeah, maybe.
LSP.
We have to create a name for it.
Well, there is already pseudo-wire redundancy, but you're doing something more than what was
Yes,
defined.
that's more. Yes, maybe a new mode. It's not 1-to-1, 1+1. It's something
No,
new.
it's a form of 1+1.
It is something like that on the transmit side, but not on the receive side.
It's a form. Okay.
It is.
I think it is even on the receive side.
Yeah.
But it's a
Okay.
new
Sure.
form.
A new form. Yes. Absolutely. Absolutely. So we can also do it on the IP traffic. Obviously, there is, the LSP itself does not have a control word, which we can add a sequence number to it. So we have to use a pseudo-wire control word. So for IP traffic, we could use IP pseudo-wire, which already there is defined in IETF. So that's, for time being, that's what we have right now, unless somebody proposes something new. So for Ethernet, it's obviously pseudo-wire. For IP traffic, we could still use IP pseudo-wire, but because pseudo-wire already has the control word. But if not, then we have to define something like a control word for LSP if we wanted to. Yes.
Hi, Yuji from Fujitsu, and one question on this slide, and it shows a stream split on the right side to LSP or one pseudo-wire. And my question is this leveraging unidirectional pseudo-wire or
Yes.
point to multi-point?
Unidirectional pseudo-wire, yes.
Yeah, my question is maybe given that it is a point-to-point pseudo-wire, now its pulse is developed bidirectional as a default. So yeah, I'm still struggling myself. This is leveraging to unidirectional pseudo-wire, right?
This is unidirectional pseudo-wire, yes.
Yeah, it sounds something new.
Why? We already have a unidirectional pseudo-wire.
Unidirectional, okay. Okay, talk to you.
We can talk later. Okay, so from a relay system point of view, one way we could view it is as a multi-segment pseudo-wire, because we want to terminate the tunnel and start another tunnel. So then really this becomes, and we want to keep the pseudo-wire label. So basically that becomes like a multi-segment pseudo-wire if you are going to have a bunch of relays in the middle. And so as I told you, the new functionality that we require right now on the receive side is to packet by packet selection between the path A and path B on the receive side. That's the requirement we need. I think Norm talked about this destination MAC address issue, that if you have Ethernet switches in the middle of the network, then you require, and you want to still support this seamless redundancy, we require some special, multicast MAC addresses. Those are things that have to be discussed. And there are also some optimizations you could do, like if or some interworking. If you receive an A2.1CB packet which already has sequence number, you may be able to map that to a pseudo-wire sequence number, or there are some of those optimizations that are possible, or you could even totally eliminate the A2.1CB header completely and just convert it to a pseudo-wire. And also the control channel is still open issue. How do you set up this, the two ends to agree on this new mechanism? And the other one that Uni has mentioned says many people consider MPLS as very heavy weight carrier grade technology, which I don't think it is, but anyway, so that's maybe of concern for some people. That's it. Any questions?
I'd just like to remind folks that this isn't even a draft yet.
Yeah.
So this is just to get the discussion going
Exactly.
on candidate data plane technologies that we should be looking at. And the target for the working group is to have enough of a discussion that after the next IETF, we can look to adopting something as a draft. And it is no problem with, like in the architecture document, there's no problem at this stage to have multiple candidates that come in and we end up adopting, and then we eventually down select to what is the right for the right choice for the working group. So this is the start of the discussion.
Do you want questions now, or should we wait?
I was going to finish my statement, then ask you for questions.
Do what?
No, wait.
You had to wait about 10 seconds, and it was going to be your time. No, stay there.
Wait,
Stay
wait.
there. Okay. Anyway, I was just, as I was saying, this is the start of the discussion. That said, now we're ready for questions.
Yeah.
Gotta wait
Yeah.
3. Yeah, we do have a few minutes for questions.
Okay. Craig White. Not really questions as much as perhaps comments or something. I think this is, to me, where the network coding fits in, and as an option perhaps, because essentially you free up some bandwidth and you potentially gain some benefits by doing that, erasure coding or assist on storage kind of things, whatever applied to network. The other thing is that in the DetNet packet, do you have the precise timestamp? Because one of the things that was kind of playing in my head was like, if you've got multiple paths showing up at one place and you're going to then discard one, if the path is shorter, then the packet's going to show up. So therefore I need to now keep track of which ones I've sent and haven't sent. But it seems like that with your precise timestamp that you would be able to, disambiguate whether that packet shows up too late, I could throw it away, or I keep it for a little bit of time, I've never heard it. I mean, there's a lot of...
Yeah, I can tell you. So 822.1 CB does not have the timestamp. It just relies on a window, because tracking window, which based on the delay in your network, somebody should configure that window. For example, it says, a 256 sequence number size, or 512 or 1K, whatever. Yes, exactly. It's a circular one.
If you're going to have a conversation, we got to do it at the mic, just because we do have remote participants, including the author of the document, of the slides.
Yes. So actually, it's a circular sequence number tracking system. Yes.
Norm Finn, something I'd like to ask the people who are thinking about network coding to consider, because I'm hoping it can bring some cool features. So something to think about is that typically this data is generated, transmitted, and consumed within a short period of time. Right, it's real time, and that's the main thing. Is that needs to is that may or may not be relevant, but I hope to hear more.
Yeah, no, not that I'm an expert by any stretch of the imagination. The interesting thing with network coding is that it gives you the ability to define the code, send that as part of the packet to decode it at the other end. And so you can have very lightweight decoding mechanisms that's sent as part of the packet. So it's not, you don't get double the amount of bandwidth. It may take 1 1/4, right? Because you're having to add information in order to recover it at the other end. but it can work at arbitrary places in the network. So that, you know, the two points that want to participate, because they have a multiple path to an endpoint, they can then add a coding so that it can be recovered at each end with some arbitrary network in the middle that could fail.
Yeah.
So it just has some really unique properties.
Yeah, I think the comment, the response that Norm was making is that network coding tends to come with an expense of either variable or fixed latency, and that may not be that latency may not be acceptable to the application. And by the way, I'm a huge advocate and fan of network coding. It just, we have to look at what the application requirements are, and sometimes it's applicable and sometimes it's not. If there's a role for it, as I said, I'm a big advocate for network coding, so that's great. I think Pat's going to close this out.
Yeah, so I'd once again encourage anybody who wants to participate in some further drafts, either contributing or some more view of the existing drafts, to come up to the front, and we will discuss how to coordinate that and run it. And
okay, so thank you very much for a successful first meeting of the DETNet Working Group. We look forward to your participation informally now for those who are interested on the list and at the next IETF. Thank you very much.